Hello and welcome to section 11-2 where we're going to be working on the area of a trapezoid, a rhombus, and a kite. So we're going to have to remember the properties we learned just a bit ago about these different shapes, and we'll apply them to our formulas. So for the properties of a kite, we know the diagonals are perpendicular, so that's where we have our 90-degree angle. One diagonal is the perpendicular bisector of the other. One diagonal bisects a pair of opposite angles. One pair of opposite angles are congruent, and two disjointed pairs of consecutive sides are congruent. So what that means is we have congruent. These are congruent as well. And we have opposite angles are bisected, which means that we've got these congruent angles and then these congruent angles. So we have a bunch of relationships going on. How do we use these to find the area? So let's explore what the formula would be for the area of a kite. And to do that, we're going to use the formulas for the area of a triangle. So if we look here, we see that we have two triangles, A, D, B. So if we were to do base times height divided by 2, we've got, I'm actually going to say it as the area of a triangle equals 1/2 the base times the height. So if I take 1/2, and the base is dB times dB times our height. Let's just put an x value here so we can track this. So our height here would be AX for this green triangle. Now if I take my next triangle, which is going to be CDB, it would be 1/2 the base, which would be dB, times the height, which would be XC. So we have this altitude here would be my height. So if we want to get the area of the kite, I'm going to take my 1/2 dB times AX and add to it my 1/2 dB times XC. So hopefully you remember factoring. I have some terms that I can factor out here. Nope, forgot a parenthesis. So I'm going to work up and I'm going to factor out 1/2 dB. And then I'm left with AX plus XC. Because I factored out the circle terms. And I'm left my AX plus my XC. Now, couldn't I replace AX plus XC with 1/2 dB and make it from A all the way to C? A all the way to C, because I'm adding them together anyways. So I get A to C. All right, so why have we done all this? Well, the reason we've done all this is because the formula for the area of a kite, so we're going to do it here, the area, and I'm going to put K for kite, is we have our 1/2, and dB, from D to B, this represents a diagonal, so I can say diagonal 1, and AC here represents the other diagonal, so we have diagonal 2. The formula for area of a kite is 1/2 diagonal 1 times diagonal 2. So let's give it a try. We know the formula again is the area of a kite equals 1/2 diagonal 1 times diagonal 2. So find the area of a kite with diagonals of 8. So let's just say A to C is 8 and B to D is 12. The area of the kite equals 1/2 8 times 12. These will cancel, so we've got 4. So the area of the kite equals 48 units squared. If they don't tell us what the measurements are in, I use it as units, or I leave it as units. Okay, so I'm going to start you with the next one, and hopefully you can get through it yourself. But look at the congruency marks, because I don't have measures of the diagonals, but I know that these are all congruent. Oops, sorry. So if they're congruent, this is going to be 5 and this is going to be 5 as well. So remember, diagonals create perpendicular angles, so I can put a nice right triangle in here. Think about the type of triangle that this would be. It's a right triangle. We have a 5 for a leg and a 13 for a hypotenuse. You should be able to determine what this measure would be so that you can then get the entire diagonal. So I'm going to leave this one for you to solve, going on from here, please. And then we will enter our answers in Google Forms. Okay, so dealing with a rhombus, you can do two things. So remember, a square is also a rhombus. It just got tipped over, so if I pushed it on this corner, it would become a rhombus. And with a rhombus, we can use the same formula. So we can do area equals base times height, remembering that you'd have to get the altitude here for your height. And then wherever this altitude lands, this becomes your base. So don't forget about how to find your base. So that's the first formula you can use for a rhombus. You can also use the area of a kite. So you can use the area equals 1/2 diagonal 1 times diagonal 2. That will work for you as well because you're multiplying the diagonals and you're taking half that amount. Either one. Okay, so now we're going to do problem number 1. And the area of a rhombus is 84 inches squared. So if I have a rhombus, the area here is 84 inches squared. One diagonal is 7 inches. What is the other diagonal? So since they're referencing diagonals, they must be using this formula, diagonal 1, diagonal 2. So plug in what you know. I have one diagonal that's going to be 7 inches. 7 inches. So the total area is 84. Plugging in what we know. The area, 84 equals 1/2. One of the diagonals is 7, and the other one we do not know. So I'm going to just call that x. Where's my eraser? I like to just use my go-to variable, which is x. And x is going to equal the other diagonal. Diagonal. All right. So I'm going to make this easier for myself, and I'm going to get rid of this fraction. So what I would do is I would multiply both sides of the equation by 2/1. Cancels. Multiply by 2/1. And I end up getting 168 equals 7x. Divide by 7, and x is going to equal 24. So the answer would be, therefore, the diagonal is 24 inches. Bang. All right, so now you have another one. Find the area, again, area of a rhombus. You have your two formulas you can use, whose perimeter is 52 and whose longer diagonal is 24. So you have a very similar situation here, but they're giving you the perimeter. So how could you back into that? I'm going to let you work on this one just a little bit. Remembering you can figure out the perimeter because it's a rhombus. All sides are congruent. And we'll finish going over that tomorrow, but give it a try. Okay, so our last shape of the day is the area of a trapezoid. Now, when I think back to how I learned it, I was told that this is the formula for area of a trapezoid. You average your bases, you multiply it by the height, and you divide it by 2. So that's great if you understand that that's the formula, but let's explore exactly what that means. So what I did here is I copied the trapezoid, and I flipped it over and then attached it right here. And I went, cool, it's a parallelogram, which I'm sure you're amazed by right now. But for the formula for a parallelogram, the area of a parallelogram equals base times height. So if I take the base, I'd have to add together my two bases to get the base, and the height would be the altitude, just like I would have for a parallelogram. But the only difference is to create this parallelogram, I needed to add another trapezoid to it. So that's where we get down to the dividing by 2. So here, I'm adding my two bases, I'm getting my height, and then I divide it by 2 or multiply it by 1/2 because it's not actually a parallelogram, it's a trapezoid. We created the other trapezoid in order to make this beautiful shape, so that's why we're taking half of it. So that's the principle behind where the formula came from. As long as you understand that that is the formula, you are as good as gold. So now we need to find the area of an isosceles trapezoid. This is key. It's isosceles, which means that the legs here are congruent. So if this side here is 8, this side is here would also be 8. And that matters for purposes of finding our base. So we know it's a 30, 60, 90. So across from the 90 is 2x rather. So that means across from the 30, it's going to be 4. Because 8 equals 2x, so x equals 4. My height's going to be 4 radical 3 because that's across from my 60. Now it's important because in order to find my base, I have one base here, I need to find my second base. I know it's an isosceles trapezoid, therefore this triangle base will be 4 as well. And in the center here, we've got this beautiful rectangle, so there's going to be my 12. So let's start plugging it in. The area equals 1/2 my height, which is 4 radical 3, times my base is 12 plus, let's see, 4, why am I struggling? This is 20. So we end up with the area equals 1/2 4 radical 3 times 32. I'm going to cross cancel, make this be 2. So the area equals 64 radical 3 units squared. And that's how I get the area of my isosceles trapezoid. Alrighty, so go ahead and give this one a try. And here's my hint. You might want to maybe do a little something like that. And then you can maybe figure out information from there as far as how it would work, knowing that this would be 90 degrees. So I'm just going to throw that out there for you and just start playing with this and see what you come up with. Thank you.